Hello everyone! Welcome to a little discussion on mid-segments of triangles. We're going to read through these definitions right here together and just do a little work on kind of highlighting some key details. I'm going to do some examples for you, and then you are going to be on your way. All right, so we kind of talked about mid-segments the last time we were in class together, and we drew that triangle and we connected our midpoints, DE, and we found out a couple of things, right? We found out that the length of DE is exactly half of the length from A to C. We also found out that this mid-segment that connects the two midpoints actually is parallel to the third side. So they are going to have equal slopes. So a lot of times what will happen is even when you connect these points, one of the things that we may not always remember is that as you make a mid-segment, this length here from D to E has to actually be, because it's going to be exactly half of this third side that it is parallel to, that it is actually equal to, in this case, DF would be congruent to the length from A to E. And those relationships hold true as you create different mid-segments on the triangle. So another relationship that would hold true, for example, would be, let's see what they're saying right here, from B over here to F, right? And F is equal to C. I'm sorry, not F is equal to C, but FC is equal to from B to F. Okay. And what is also going to be true then is that DE is also equal to each of those components. So anytime you have a mid-segment, remember it's exactly half of that side that it is parallel to. And then there's some nice information here if you would like to stop your video and kind of check that out. The mid-segment theorem states that the mid-segment connecting the midpoints of two sides of a triangle is parallel to the third side. That is the other thing we discovered the last time we were together in class. And the only thing we really didn't get to, okay, is a little bit of discussion around, for example, what it means for two lines to be parallel in a triangle like this is that all of our relationships that we've talked about for parallel lines also hold true for these two parallel lines being cut by a transversal, for example. So we didn't really get a chance to touch on the fact that because this side of the triangle is actually cutting through two parallel lines, that this angle here at the vertex of the larger triangle must be equal to this angle here at the vertex of the smaller upper triangle, because those two angles that I've just marked are corresponding angles. So you're going to be working a lot with corresponding angles as we move through this section and the next, talking about similar triangles and congruent triangles. Okay, so all of the vocab we learned around parallel lines being cut by a transversal, remember they look like this. Two parallel lines cut by a transversal. We had all that vocab. You're going to need to know it all, okay? So if that's something you need to review, make sure you do that. All right, a couple of examples. Pretty straightforward here. The measure from C to D, of course, because it is a mid-segment, is going to be 7 if this side is 14. Over here, we're finding from K to L, easy, smaller, exactly half of H to L, so we have a length of KL of 9. And then the setup for taking care of a problem like this, as you are given a piece that actually has to be multiplied by 2. So times 2 is going to be equal to the longer base that it is parallel to. So the setup is going to be 2 times your mid-segment, right, is going to be equal to that third side. And that's going to be true every time. So the setup for this one is going to be 2 times your 2x minus 9, just like that, is equal to 3x minus 8. I'll show you some algebra here if I can make it through this example without too much difficulty, hopefully. There we go. We'll add 18 to both sides, guys. And as we continue here, it looks like we have 4x equals 3x plus 10. And if we subtract 3x from both sides, we get x equals 10. All right. So you guys try this one. Try it, please. Which means to try it, you're going to have to stop the video right here. And then after you give this a try, magically, when you restart the video, the answer will appear down here. Okay, stop and try. Poof! Just like that. All the work is there for you to review. If you need to stop the video again, you may need to if you want to kind of take a closer look. But if you got x is equal to 10, you guys are off and running. All right, guys. Good luck with these assignments on mid-segments. We'll see you in class.